Hello, I am Brent Gunnoe, and I would like to welcome all prospective graduate students to the brief video overview of research in the Gunnoe Group. Our research is focused on the development and study of new catalysts for a broad range of applications, including both thermal and electrocatalysis. We have interest in areas as diverse as catalytic CH functionalization chemistry, electrocatalytic water oxidation chemistry that can be applied to fine chemical synthesis, energy processes, as well as large commodity chemical synthesis. Currently, our research group is funded by 2 grants from the United States Department of Energy, as well as 2 grants from the National Science Foundation. Our efforts are highly multidisciplinary. In our group, we primarily focus on the design and understanding of well-defined molecular catalysts, but we also seek to integrate these types of catalysts into advanced materials for heterogeneous applications, both in thermal catalysis as well as in electrocatalytic materials. Our group has multiple collaborations both within the Department of Chemistry at the University of Virginia, as well as outside of the Department of Chemistry with some engineering programs. In addition, we benefit from multiple collaborations with scientists from all across the United States and in fact across the world. We hope that you'll find this brief overview of our research group informative, and we encourage any prospective students that have further interest or additional questions to please reach out, contact me, as well as any of the graduate students or postdocs in the group would be happy to interact and answer any questions you might have. Thanks so much.
Hi, I'm Hannah Ketchum. I'm a second year from Syracuse, New York. I'm on the Aryan alkylation project. So with the Aryan alkylation project, we take benzene and ethylene with our catalyst, and we use it to create styrene, which is an important precursor in the chemical industry.
Most of the reactions are performed in high-pressure reactors. Before the reaction, everything is dissolved in benzene, and the reaction color is a nice blue. Then the high-pressure line is used to pressurize a certain amount of ethylene. The reaction will be put in an oil bath and run for a couple hours. Then the mixture will be further analyzed by the GC-FID in order to get the turnover numbers, which is an important factor to evaluate the catalysis.
Hi, I'm Kaylee, a third-year graduate student in the Gunnoe lab from Sterling, Virginia, working on light alkane partial oxidation. As the utilization of natural gas, composed primarily of methane, ethane, and propane, is hindered by the challenges associated with its transportation from the wellhead, we're interested in investigating its conversion into liquid products that can be stored, transported, and then used directly as fuels or as precursors to higher value chemicals. The main challenge facing partial oxidation of light alkanes is chronic overoxidation due to the fact the CH bond of the oxidized alkane is weaker than that of the alkane itself. Our lab has discovered a process termed oxyesterification that oxidizes light alkanes to alkyl esters using metal oxidants and chloride salts and carboxylic acid containing solvent, where the ester group effectively protects against overoxidation. As an alternative strategy, photolysis allows for milder reaction conditions, and we've seen success in subjecting our thermal process instead to UV light. Current efforts include extending the photo-driven process from traditional oxidants to photocatalysts. Alongside other academic chemistry labs, national labs, techno-economic analysis, and industry partners, we're all tackling this research together to move this project toward commercialization.
My name is Chris Weber. I'm from Shippensburg, Pennsylvania. My primary area of research concerns water oxidation through electrochemical processes. Water oxidation is a very important part of renewable energy because it allows for storage of energy from renewable energy in hydrogen gas, which when burned does not produce any greenhouse gases. We here in the Gunnoe group primarily focus on homogeneous catalysis using first-row transition metals.
Hi, I'm Anna. I'm a postdoc here in the Gunnoe lab. I'm from Spain, and I'm also on the water oxidation project. Water oxidation is a challenging reaction, and in the Gunnoe lab we believe that it's not something that we can tackle on our own, and we think the best approach is to have a multidisciplinary approach to it and to have work together with several groups. So the water oxidation project is a very collaborative project. So we're working with the Young Lab here at UVA, and they're actually experts in electrochemistry for energy applications and in material synthesis. So they're making conductive carbon materials where we can attach our catalyst and make molecular anodes that can help for this reaction. But it's not just this, we're also working with the Goddard group in Caltech. And what they're doing is that they're doing DFT calculations to find out the reaction pathways for these reactions, but also they can predict with catalysts might work better for water oxidation, and then we can go on and make them in our labs. So hopefully with this multidisciplinary approach, we can find the solution to tackle this real problem.
Hi, I'm Zoe, and I am a second-year student in the Gunnoe group. My research focuses on CH functionalization of hydrocarbons using group 9 metal complexes. Our group has developed a series of novel ligands with the goal of controlling the energetics of the catalytic cycle. The +3 oxidation state of the metal is often very stable, which can result in inhibited catalytic activity. So to combat this challenge, our group has developed a set of capping arene ligands, which block one of the coordination sites on the metal center and prevent formation of a very stable 18-electron octahedral complex. We utilize different ligand backbones in order to change the distance between the metal center and the capping arene. The longer the distance has a lesser electronic interaction with the metal center, and less electron donation destabilizes the +3 oxidation state on the metal to promote reductive elimination of the product and return the complex to the +1 metal oxidation state.
Hi, I'm Fanji. I'm currently working on 2 projects, copper-mediated CH activation and development and application of a new antimony-based ligands for late transition metal. In our group, pursuit of students' own idea is encouraged as a part of becoming an independent chemist. Now, in my case, a few months ago, after listening to a talk by a seminar guest, I had an idea of modifying the structure of our capping arene ligands with a moiety that can serve as a sigma acceptor to modulate electron density at the metal center. So I decided to discuss my idea with Dr. Gunnoe, and we developed it further. As a result, it now become one of my new projects. So currently, I have already made 6 new antimony-based ligands and a few new hydrometallic complexes as an extension of our capping arene complexes. And I am very excited about pursuing elucidation of the reactivities of those new complexes.
In the Gunnoe group, when you first joined the lab, you were assigned to an existing project with an upper-level graduate student. This senior student acts as a mentor and helps you to integrate into the lab. Your mentor teaches you all the necessary procedures for laboratory work in the Gunnoe group and helps you to get established on your first assigned project. They also act as a first point of contact if you have any questions regarding laboratory work or course material. Due to this collaborative process with the senior graduate student in the group, I was able to assist in research for a publication that I am a co-author on, and now using the skills and knowledge that I have gained working on that project, I am able to pursue my own independent projects.
Hi, my name's Chris, and I'm a first year in the Gunnoe lab. When I first joined, I started on the group's training manual and learned all the techniques I need to do my research. And right now I'm starting my independent research on the group's arene alkylation project.
Hi, my name is Mark. I'm a second-year graduate student here in the Gunnoe lab. I, along with the 3 other second years in this group, Chris, Hannah, and Zoe, recently passed the second-year candidacy exam. We were able to accomplish this in large part due to the extremely supportive and collaborative nature of the Gunnoe group. We'd encourage you to join the Gunnoe group because we love it and we know you will too.
Thank you for your interest in our group. If you have any questions, feel free to email any of us. Our emails are all on our website.
And we look forward to seeing you this fall.